Okay, so when you see one of those high voltage warning signs, what's the first thing you think of? For most of us, it's that huge number, right? All those volts. But what if I told you we've been focused on the wrong thing this whole time? Today, we're going to uncover the surprising and honestly much smaller culprit behind why electric shock is so dangerous. Let's get into it. To really get why this matters, we have to take a quick look back. I mean, electricity has been in our homes for over 100 years, but our understanding of its dangers? Well, that's been a pretty slow and often a really fatal learning curve. You're not going to believe this, but back in the 70s and 80s, electrocution was responsible for a staggering 30% of all workplace deaths. Just let that sink in. Nearly 1 in every 3 fatalities. It just goes to show how common and how misunderstood this danger really was. Now, thankfully, things are a lot safer today. We've got advanced circuit breakers that can cut the power in a fraction of a second. But here's the thing. While our tech has gotten way better, the basic physics of how electricity messes with the human body hasn't changed one bit. The danger is always there, just waiting for a single mistake. And this brings us right to the heart of the issue. This fundamental misunderstanding that a lot of us still have about what electricity actually does to us. No, seriously, think about it. You see that classic sign, the one with the lightning bolt. The first word that pops into your head is probably voltage, isn't it? High voltage means extreme danger. That's what we all think. And yeah, that's the big misconception. We've all been trained to see a big voltage number and think that's the big threat. But while it's definitely part of the equation, it is not the actual killer. So it's time to meet the real culprit. All right, so if it's not voltage, what is it? The answer is, it's a lot more subtle. And to be honest, it's way more frightening because of just how little of it you need to cause serious, serious harm. And there you have it. That's it. This is probably the single most important thing to take away from all of this. It's not the volts, it's the amps. It's the current, measured in amperes or even milliamperes. That's what actually stops your heart. That's what does the damage. So what's voltage even for then? Well, think of it like this. Voltage is like the water pressure in a hose, and the current is the actual water flowing through it. The pressure, that's the voltage, determines how much water or current can flow. So yeah, higher voltage can push more current through you, but it's the flow of that current that does the real damage. And the amount that's lethal it's shockingly small. As little as 100 milliamps, that's just 1/10 of an amp, can be fatal. That's enough to cause something called ventricular fibrillation. It's a terrifying condition where your heart's electrical signals just go completely haywire, and it just quivers, totally useless, instead of pumping blood. To put that into perspective, because, 100 milliamps sounds pretty abstract, but look at this. A tiny little 10-watt light bulb needs almost 10 times that much current just to light up. So the amount of electricity that can literally stop a human heart is just a tiny fraction of what we use for everyday things without a second thought. Okay, so we've got voltage as the pressure and current as the deadly flow. But there is one more crucial piece to this puzzle. You. Your body is the conductor, and its condition can change absolutely everything. You see, the one thing standing between you and a lethal flow of current is resistance. Your skin naturally has a really high resistance, which is great. It limits how much current can pass through. But that natural armor, it has a major, major weakness. And this table right here just lays it all out. When your skin is dry, it has a massive resistance. We're talking up to 600,000 ohms. But look what happens when it gets wet. That number just plummets, all the way down to 1,000 ohms. It's like you're opening up a superhighway for electrical current to pour right through your body. And that's the critical point. When your skin is wet, your body's defenses are basically gone. All of a sudden, the pretty low pressure of a standard 120-volt outlet has more than enough push to send a fatal dose of current flowing right through you. This is exactly why using your phone in the bath or a hairdryer near the sink is so incredibly dangerous. So let's just hammer this home. Let's recap the essentials. First, the real killer is current, not voltage. Got it? Second, it takes a tiny, tiny amount of that current to be fatal, way less than what a simple light bulb uses. And third, water is the game changer. It absolutely shatters your body's natural defenses against that current. So knowing this really reframes our whole idea of electrical safety, doesn't it?
The biggest threat isn't always the giant power line buzzing overhead. It could be the simple wall outlet right next to your kitchen sink. The next time you go to plug something in with wet hands, just remember, it's not the voltage you should be worried about. It's the tiny, unseen current that truly demands your respect.